Yesterday I talked about the signs.
Alright, so yesterday we talked about laws of sines. Today we're going to talk about laws of cosines. So, solving a right triangle or solving a triangle that is not a right triangle, once again, we cannot always just use law of sines. We're not always given enough information to use that. So when that is the case, like up here, think about that. Can you use law of sines? Can you use law of sines on this problem right here? How many people think yes you can? How many people think no you can't? Total of 5 people voted. Let's try that again. How many people think yes you can? How many people think no you can't? Wow, that's a lot more hands that time. Alright. Why can I not use law of sines, Violet?
Because you need an angle and then the corresponding side.
Exactly. We need an angle and a corresponding side. We do not have that. We have 2 sides that don't match an angle. We have an angle that doesn't match one of the sides. We don't have matching sides and angles. So, because of that, we're not able to use law of sines. However, we can use what we call the law of cosines. The law of cosines. If it's the same triangle, right? Side lengths A, B, and C, angles A, B, and C. This is our law of cosines. So if I'm looking for side A, I'm going to do A squared equals B squared plus C squared minus 2BC times cosine of angle A. If I'm looking for B squared, what happens is my B's and A's flip. B squared equals A squared plus C squared minus 2AC times cosine of B. Right? Same thing for C squared. Or if I'm looking for an angle, cosine of A equals B squared minus or plus C squared minus A squared over 2BC. Vice versa, it fills in, right? If you want to look for B, find B then. Now, you do not need to memorize these. These will be given to you on the test. Alright? That doesn't mean you shouldn't learn them. Actually, once you use them a bunch of times, you'll probably remember them. But you do not need to memorize them. You'll be given them on the test. You just need to know, how do I use them? Alright? Does that make sense? Are there any questions at this point? Yes? No? Maybe? Okay. Alright, well, let's try and use them. For example, so we use these. When we're trying to find the third side of a triangle and we know 2 sides at an angle, like we just saw on the page before. Or, if we're just given all 3 sides of the triangle, we can use it to find one of our angles. Now, once you use this once you use law of cosines once, you should be able to use the law of sines to keep figuring it out. Alright, so all you do is use law of cosines once, then law of sines will work to figure the rest of the triangle out. Because I assume most of us are going to like law of sines better than law of cosines. What's so funny? Okay. Quentin got a mirror in the back of his head?
No.
Okay.
Now.
Alright, so our first problem here. Number 1, we want to solve this triangle. We're going to use law of cosines to find our third side so we can solve our triangle. Now, on here, it's labeled X, Y, and W. Do you think it's okay if we change those to A, B, and C? So they fit our formula?
No. Yeah.
Yeah, that's perfectly fine as long as when you're answering the questions, you still remember where X, Y, and W are. Alright, so I'm going to let one of X be A, Y be B, W be C. Alright, so which side then am I technically looking for? A, B, or C? If I let X be A, Y be B, W be C.
A.
I'm looking for A, right? It's across from angle A. So what I'm going to do is I'm going to use that first formula. The one where I'm looking for A squared. So A squared equals, well, B squared is across from my B. So it becomes 5 squared plus C squared. C is across from C. So 5 squared plus 3 squared minus 2 times 5 times 3 times cosine of A, which is 32 degrees. Alright? Any questions about that? Honestly, once you're right here, you can plug this whole thing into your calculator. Now, what I would say is be careful when you're plugging in your calculator though. Alright, I would go into my calculator, I would do 5 squared plus 3 squared minus, and in parentheses, I would put 2 times 5 times 3. Oops. Times 5 times 3 times, what do you say, cosine of 32? So once you have your law of cosines written out there, you can put in your calculator, and boom. So we get, where's the notes? A squared equals 8.558557115. Right? Do we all follow how I did that? So I get a squared equals, what's that? 8.55855. Right? That's what we get for a squared. What am I looking for a squared?
No.
No, I'm looking for
A.
a. So what should I do to this? Square root it. So square root both sides.
I'm not getting.
You're not getting that? Did you punch in your calculator? Is that what you're doing? Did you put the second part in parentheses?
No, I just simplified everything up to the cosine. And then
Okay, well you can't subtract before you multiply. That's our problem, right? That's why I made sure we put it in parentheses. If you do simplify it first, you do like 25 plus 9 minus 30 times cosine of 32. You can do 25 plus 9 first. You can do 34, but it's got to be minus 30 times cosine of 32. We cannot multiply before we subtract. Alright? So you would have to do 30 times cosine of 32 and then do 34 minus that. Alright? Now, like I said, I would just punch it into my calculator from here. Make sure I put this part in parentheses. Okay, so when we take the square root of that, I would go, oops, not drawing here. Square root, second answer, hit enter. What do we get? 2.93. So A is approximately 2.93. Now A is really side X, right? So down here I write 2.93. Now, I have an angle and a side that match, so now I can start using law of sines again. So, which angle do you want to solve for, Jalen? C, you want to solve up here? Okay, so we'll go up here. That's what we're going to solve for next. So I'm going to use angle A and side A, the ones that I just found. So sine of 32 over 2.93 equals, I want to find C, so sine of C over my side length of 3. How did we solve these yesterday? We cross multiplied, right? Same thing, cross multiply. 3 times sine of 32 equals 2.93 times sine of C. Well, divide by 2.93. So you get 3 times sine of 32 over 2.93 equals sine of C. Do I want the sine of C? Or am I looking for? Just C, right? So how do I go from sine of C to just C?
Inverse.
Do the inverse sine, right? So whenever we're looking for an angle, we're going to have to do an inverse sine. So take the inverse sine of both sides. Well, they're going to cancel. So the inverse sine of 3 times sine of 32 over 2.93, and that's an angle. So we're going to the nearest whole degree. What are we going to get? What do you... What? 65. Well, I didn't get that.
32.
Let's try it. 3 times sine of 32. right? Divided by 2.93. Inverse sine of my answer, 33. When you round up? Did you try it again? Okay. So 33 is what our angle measure should be. 33 degrees. Now angle C is actually angle W. So make sure you put that in the correct spot. 'Cause if you put it for Y, you get it marked wrong on a test. Right? It's actually W. So I have 32 and 33 degrees. And how can I find that last angle?
33 plus 32, 180 minus the answer.
180 minus the answer, right? So take 180, subtract off our other two angles. Should give us 115, right? So 115 degrees for my last angle. So guys, the big thing here, we only need to use law of cosines once before we use law of sines, okay? It's a big takeaway. Now if you want to keep using law of cosines to find other angles and sides and stuff like that, you're more than welcome to. But I just think law of sines is a little bit easier. Okay? Any questions on that first problem? Alright, do another one. So that was when we were given two sides and an angle. Our next one, we're given all three sides. Right? So we're not given any angles. So we need to solve for an angle using law of cosines. So that's going to be one of those ones where it says cosine of A or cosine of B or cosine of C equals. That's the one we use when we're solving for an angle. These are solving for sides, solving for an angle. Okay? Now, a hint, maybe I'd write down on my paper, if we're given all three side lengths, I would always start by finding the smallest angle first. How do you know which one's going to be the smallest angle? Let's think about it a little bit. Which one's going to be the smallest angle? The what? Where the two longest sides connect, or the one that's across from the smallest side, right? So yeah, Colton, so where the two longer ones connect, or the one that's across from the smallest side. So I'm going to find this angle right here first. What happens, why we do that, is because when you solve for maybe the second biggest or the biggest angle, we sometimes get ambiguous cases, which means we get answers that shouldn't really be answers. Alright, so to eliminate that possibility of happening, we're always going to solve for the smallest angle first. Okay? Make sense? Okay, so let's do that. So I'm going to let W be A, because I have it set up for my angle A to be right in there. So I'm going to let W be A, I'll let X be B, and Y be C. Now, you don't have to do that. You can use W, X, and Y all you want. That's perfectly fine, but I'm just more comfortable in my head using A, B, and C, so I'm just going to rename them. It's perfectly fine. All you're doing is changing a variable. Okay? So cosine of A, cosine of angle A, cosine of angle A, right? I don't know A, so it's just going to stay like cosine of A equals, well, side B is across from angle B, side C is across from angle C, side A is across from angle A. So B squared would be 4.8 squared plus C squared would be 3.5 squared minus A squared, which is 2.8 squared, over 2 times B times C. So 2 times 4.8 times 3.5. Now, be careful punching it into your calculator again. I would maybe do all of the top, and then do all the bottoms separately, and then divide them. So like I would do cosine of A equals, and then I would do...
Do we have to put cosine of A in our thing? I thought we had to put cosine A in our equation.
In your equation, what do you mean?
Oh, my bad.
So yeah, so cosine of A is what it equals, right?
Yeah.
So I'm going to leave it over there, because I'm looking for that variable. So I would do 4.8, oops, that's not squared. 4.8 squared plus 3.5 squared minus, what was the other one, 2.8? 2.8 squared. Then I would hit enter. So 27.45 over, and then I would do 2 times 4.8 times 3.5, 33.6. Now, if you want to put that whole thing up here in your calculator right away, you're more than welcome to, but just be really careful when you do it. Right? If you mess up on one thing in there and you get the wrong answer there, your whole problem's going to be messed up. So take it step by step, do it slowly. If you're going to put all of it in your calculator, make sure you're putting parentheses around your denominator so it multiplies before it divides and things like that. So in your calculator, we do 27.45. 27.45 divided by 33.6. So cosine of A equals, what's that? I lost it. 0.81696, right? I'm not looking for cosine of A though. I want A. I want angle A.
Inverse.
Do the inverse. Right? Inverse both sides. So inverse cosine. Inverse cosine.
35.
Second cosine. Second. Pull your answer. Oh, that's pretty embarrassing. Phone going off in the middle of class.
Take it away, Mr.
Sheesh.
Take it away.
Red face.
Patrick, it's enough of that.
Sorry.
So we should get A is 35 degrees. Right? So 35 degrees. Alright. So angle A is actually which angle?
W.
W. So make sure you write on the correct line. A lot of you will be really upset with me when you write the angles on the wrong lines on the test and I mark them wrong. Like, but I had the right numbers. And I'll be like, well, you put them in the wrong spots. And so make sure you're being careful. Alright. Now that we did law of cosines once, we can do what? Law of sines, right? We have an angle and a side that match up, so I can do law of sines. So I'm going to do that. Caden, you want to solve, which angle do you want to solve for?
My calculator's not working.
I know, but just, which one do you want to, which one should we solve for? Let me rephrase that.
Shorter one?
The shorter one? Okay, so let's do this one.
Yeah.
Alright, so we'll go here. So we're going to do sine of 35 over 2.8, because that's the pair that I have that matches, right? The angle on the side that matches together equals, we want to do sine of C, we said, over 3.5. Alright, so we're going to solve for this angle down here first. Well, when I do that, cross multiply. 2.8 times sine of C equals 3.5 times sine of 35. You all follow me? We're good? Okay. Divide by 2.8. We get sine of C equals 3.5 times the sine of 35 divided by 2.8. And what should I do to solve for angle C? Inverse, right? If I just write this, pretty cool with that. Sounds to write it out twice. So I understand that that's taking the inverse of both sides. Oh, here, I'll just write it out. You guys look confused. So inverse sine of 3.5 times sine of 35 over 2.8 should give me angle C. Alright, so in your calculators, do that. Inverse sine of 3.5 times the sine of 35 over 2.8. We know what we get.
We got 46.
You got 46? It's like a wheel, like you use your partner up there.
Yep, I
Alright.
did the math and I put in the calculations and you wrote it down and
You
around.
put in the calculations. What about calculators are you using?
You just gave it to me so I could round.
Oh, okay. Did everyone else get 46?
Yeah, it's 46.
Yeah? It is. Yes, it's 46. All right. So C,
Talking to you.
46 degrees. So that's actually angle Y. So how do you find your last angle?
46 plus 35, 180 minus 81
So,
equals 99.
180 minus 35 minus 46 should give us 99? 99 degrees. Sweet. All right?
This is easy.
This isn't too bad, right? As long as you know how to use the formulas, guys, you'll be okay. All right? One more problem.
What?
Not me. Not me. Not me.
He did that vulgar language.
What is?
I am appalled.
Alright, golfer to an air tee shot lands in the rough. Marker in the center fairway is 120 yards from the center of the green.
Oh, look at that.
While standing on the marker and facing the green, golfer turns 105 degrees towards his ball. He then paces off 40 yards to his ball. How far is the ball from the center of the green? In other words, I want to find that side over there. I'm given two angles, or excuse me, two sides and an angle. So I need to use law of cosines to find this third side. Well, law of cosine said a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Right? So all I'm going to do is I'm going to plug in my numbers into my formula to figure out what that a squared, or what that side I'm looking for is. Right? Does that make sense? Okay, so I'm going to write it out. A squared equals 120 squared plus 40 squared minus 2 times 120 times 40 times the cosine of 105. Almost ran out of room there. Does that make sense? Right? Take your two sides, plug them in for B and C. Take your angle, cosine of the angle, and then punch it into your calculator. Right? You should get A squared equal to 18,484.66283. And what's the last thing you got to do here? Square root it. Right? We got to find A. We don't want A squared. A is approximately how far? It's the nearest hundredth. Remember, we're looking for a side.
136.
When we take the square root, we should get 135.96 yards. Alright? That's it for today. Finito. Question?
Yeah, I keep getting like this domain error, I'm like,